Assalamualaikum to Dr. Huzaimah. This is the presentation of Chapter 11, Corrosion. I am binti Ismail and I'm gonna discuss about the electrochemical corrosion. So, electrochemical corrosion is a process that occurs when two different metals contact to each other in the presence of an electrolyte. In electrochemical corrosion, there will be redox reaction. Redox reaction include the oxidation reaction that happen on the anodic side and reduction that happen in the cathodic side. So a metal will not corrode if it is in contact with B metal only if B metal is more electropositive than A metal. For example, if we coat iron with aluminium, the iron will not have any rust because aluminium is more electropositive than iron. For the corrosion of iron can be prevented by coating iron with metal that is more electropositive, such as zinc, aluminium, magnesium, through the process called galvanization. So this is the example, coating iron with zinc. So iron will be protected with zinc. So iron will not be corroded. But if the iron is coated with the less electropositive metal such as tin, copper, gold, it can accelerate the corrosion of iron. For example, if there is any stretch on the tin, on the metal tin, iron will corrode because iron will not be protected anymore. So this is the basic example for electrochemical cell. This is the anode side. In here, oxidation will happen. Electron will move to another side, so it will lose electron. And for this side, this is the cathode side. Reduction will happen here, and it will receive electron, and the mass will increase. The mass of cuprum will increase, but for here it will lose its mass. So that is all for me for electrochemical corrosion. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh to Dr. Huzaimah binti Nazir, SITI MAIZATUL AKMA binti Muhammad NASARUDDIN, program RAS1154C, Group 4C. In this video, I'm gonna discuss about the galvanic corrosion, cathodic protection. Okay, what is galvanic corrosion? Well, galvanic corrosion occurs when two different metals or alloys with different nobilities and therefore different electrochemical potential come into contact with each other under water or in a damp environment. And in the event on such contact, the less noble act as an anode and the more noble metal act as a cathode, and it is always for anode that corrodes. So here's the galvanic series. If a normal galvanized steel screw is used to secure equipment made of stainless steel, the screw becomes anode since the stainless steel is more noble. So as you can see it here, the greater the cathode area in relation to the anode, the faster the anode will corrode. Okay, for example, the screw right here will corrode quickly, not only because the cathode is larger, but also because the electrochemical potential is great. And as you can see it here, galvanic corrosion may also occur between parts of the same metals. If the parts are situated in different surroundings, such as area with different pH values. But for this to happen, the anode and cathode must be in electrical contact with each other. Okay, so next we move to the how can galvanic corrosion be prevented when designing or installing new equipment. Is it a high quality bolt to ensure a high quality installation for aluminium signboard? Well, if using acid resistant or galvanized steel bolts to secure aluminium, we should use a non-metal washer to isolate the metals from contact each other. Otherwise, the aluminium may act as an anode. If there is no washer, then the aluminium may act as anode and corrode around the valve, and then it becomes like this. The connection will then be weakened in the event of additional external stresses such as wind. In this case, the sign may work loose and fall down while bolt is left behind. So we must remember that a weakness of the isolating washer may be the screws in bolts or bolts lose their pretension. So here are some points of good practice to prevent galvanic corrosion. Okay, first, we obtain an overview of the type of material used and structure to which the equipment will be fastened, and choose bolts that are appropriate to the relevant load and surrounding. Second, remember the basic rule in a corrosive environment, trying to use metals with the same or almost the same mobility. And third, avoid contact between different materials. If we must use different materials, we can use washer to prevent the materials from coming into direct contact with each other. And the last one, use paint as a buffer. An alternative method of preventing contact between the material is to paint the surface. And we must remember that we must paint the most noble part, which is the cathode, because if we paint the anode and a crack forms in the paint, the galvanic current will flow to the point and may result in significant corrosion. And that's are some points of good practice to prevent galvanic corrosion. Thank you. Bye.
Hello, my name is Afiqah binti Abu Bakar. So today I will explain about oxidation and reduction occur in corrosion of metal. Before move to the next content, I would like to explain what is oxidation and what is reduction. Okay, oxidation is the process in which atom loses an electron and therefore increase its oxidation number. In other words, the positive character of the species is increased. Okay, for reduction, a process in which an atom gains an electron and therefore decrease or reduce its oxidation number. Basically, the positive character of the species is reduced. Okay, for make it easy, we will look at this table. Okay. In the terms of hydrogen, for oxidation it increases and for reduction is decreases. For in the terms of hydrogen is decreases and for reduction is increases. In the terms of electron number it decreases for oxidation and it's increasing for the reduction. And for oxidation number for oxidation it increases and it decreases for reduction. So this is a summary for the meaning of reduction and oxidation. Okay, so today I will take an example, random example. The topic I choose is corrosion of zinc in acid reaction. There are two necessary reaction, which is oxidation and reduction. Okay, as we all know, acid is a proton donor, so it has hydrogen ion floating around it. So there's gonna be two reaction occur in every corrosion reaction. The first reaction is zinc, where zinc give up a couple electron and move into the acid solution as a zinc ion. So zinc goes to the acid solution. The electrons are flowing in the metal. We call this kind of reaction is oxidation reaction. So that's one of the two reactions that are required. And the second reaction where the two electrons that the zinc gave recombine with two hydrogen ions from the acid solution and form hydrogen gas. This reaction, when the material accepts the electrons that has given up by the metal, is called a reduction reaction. So these are two reactions they are required. For number one, for oxidation, zinc change from 0 to 2, so there are electrons are losers. For hydrogen, the case is a little different, which hydrogen is going from 1 to O. This means that for each hydrogen ion that reacts, one electron is needed. Since there are two hydrogen ions that are react, so two electrons are needed. Next, we'll move to the familiar or common of corrosion, which is corrosion of iron, also called as rusting of iron. Okay, in the rusting of iron, iron acts as the reducing agent and oxygen gas as the oxidizing agent. The process of rusting of iron can be explained by looking at this photo. Okay, so as we can see at this photo, when the surface of the iron is exposed to water droplets, the center of the water droplets undergoes the process of oxidation and is known as the anode. The edge of the water droplets undergo a process of reduction and is known as the cathode. The edge of the water droplet acts as the cathode because of the concentration of soluble oxygen is higher on the edge of the water droplets than at the center. Okay, at the anode, the metal ion undergoes oxidation to form the iron 2 ion with the loss of electrons. Electrons that are free at the anode flow through the metal ion in the cathode area, where soluble oxygen in the water accept electrons to form hydroxide ions. Okay, the iron 2 ions are then combined with the hydroxide ion to form iron 2 hydroxide, and iron 2 hydroxide is then oxidized by oxygen to form iron 3 hydroxide. Next, the iron 3 hydroxide is then decomposed to form hydrated iron 3 oxide by oxygen in the air, and the hydrated iron 3 oxide is brown in color and is known as rust. So these are the overall equation for the rusting of iron. Okay, so here are some example of corrosion, which is number 1 is tarnishing of the silver, number 2 is rusting of iron, and number 3 is brass and copper is covered with green color deposit. Okay, next I will explain about the ways to prevent from corrosion to occur. Okay, there are 3 ways. The first one is by surface coating, number 2 is by connecting the metal to a more electropositive metal, and number 3 is by forming insoluble phosphate or chromic coating. Okay, for number 1, for surface coating, we can use by applying oil, grease, paint or varnish on the surface, or by coating a thin layer of any other metal which does not corrode. For number 2, by connecting to the more electropositive metal, which as long as the more electropositive metal is present, so the given metal will not get corroded. For instance, you can protect iron from corrosion by connecting a block or plate of zinc or magnesium. So this method of protection is known as cathodic protection. Number 3 is by forming insoluble phosphate of chromic coating. Okay, this third way is of prevention is by treating the metal surface with phosphoric acid. It forms an insoluble phosphate coating on the surface which protects the metal from corrosion. You can also form a thin chromic layer to prevent the metal from corrosion.